Hey everyone. We all know that the power of AI can be harnessed in biology by using advanced models that can decode complex molecular patterns, accelerate drug discovery, and transform the raw biological data into insights for research and medicine, right? Let's take a look at how we can use these models for your research in life sciences on Databricks. My name is Srijit, and I'm a specialist solutions architect at Databricks in life sciences. And here we have
And
Mayank with me.
yeah, thanks, Srijit. My name is Mike Dadramani from NVIDIA. I am part of the partnership team that works closely with Databricks and bringing solutions to market. So super excited to talk to you about Genesis Workbench and all things healthcare life sciences related.
So, as I mentioned, we all know that the power of Gen AI can be used in biology, right? These language models that are available right now, these foundation models can be used for a variety of tasks like drug discovery, understanding molecular structure, and then also to understand the relationships between biological targets and small molecules so that we can suggest new binders, optimize better compounds, and develop a variety of pharmacology strategies. And we also know that diffusion models generate novel drugs. And the advantage of this is that previously the experiment that used to take years and it takes millions of dollars in the wet floor, with these models, with this technology, we can run these experiments really fast in silico, that's virtually on these computers really fast and cheap, right? So either fail fast or find optimal targets really fast. But with all that said, this power is extremely difficult to harness, right? We are seeing these scientists. I work with a lot of biopharma companies in US on a day-to-day basis, and every single day I hear these asks from these scientists. They're struggling to bring these biological models and take advantage of this power for their day-to-day work. And why is it? It's a variety of reasons. Mostly they require a lot of non-computational tasks to get these things to work, right? There's GPU that need to be set up. There need to be CUDA software that need to be set up. These models change very often. Like there's a new version every couple of weeks. There's a better model every couple of weeks. And more than anything, the work that they do in this field is extremely high IP, right? And it's need to be governed tightly. And there's a lot of security concerns around it too. So it's not just the research, it's just the plumbing that is required to get this model to work in an enterprise scenario takes a lot of toil on the scientists. So when we started seeing such patterns emerging from the field, when we hear such requests from many of our customers on a day-to-day basis, we said, hey, why don't we take these models, develop an application so that showcases how to run these models on Databricks, right? So what we set out, a few people in my team and myself, we set out on a journey to create an application which serves as a blueprint for developing such life sciences workflows on Databricks. Like it includes serving some of the foundation models for biology that's available open source, like ESM-Fold, Protein, Boltz, etc., on GPU infrastructure of Databricks, or creating large-scale batch inference workflows like AlphaFold or single-cell embeddings on Databricks workflows on GPU clusters. Or it could be also fine-tuning and managing models which are available before you can start using it, and then registering and tracking those experiments in MLflow. NVIDIA has been one of the biggest partners with us for the past 1 year, and we have been working closely together to take advantage of the NVIDIA's BioNeMo stack on Databricks. And we have been setting out patterns on how we can leverage that accelerated stack on Databricks on GPU compute and create custom workflows so that you can leverage those models on your data for your problems to solve. Okay. So let me introduce you to Mayank so that he can give insights into NVIDIA and life sciences.
Brilliant. Thank you, Srijit, for highlighting our partnership, because it's been a pleasure working with you closely, particularly in tackling the healthcare life sciences space for drug discovery. For many of you listening and tuning in, just know that NVIDIA is deeply invested in healthcare life sciences, viewing biology as the next great information science challenge, one that can really revolutionize how we enhance human health and one that is ripe for reaping the benefits of the most recent transformations and technological advancements in accelerated compute. From NVIDIA's point of view, we contribute by providing a full stack computing platform optimized for this domain. And what that means is at the hardware level, for instance, we deliver specialized AI infrastructure from H100s to Blackwell GPUs, those that you may be already familiar with, to purpose-built AI factories, those data centers that are equipped and specialized as platforms to train massive foundation models, deploy them at scale and power them real time, even with interfacing with medical devices, for instance. At the software level, however, we abstract a lot of that underlying complexity with domain-specific tools like Databricks, BioNeMo, and many others that we'll be discussing later in this session. This enables researchers to build and deploy life-saving applications faster than ever. So what you're seeing here in this slide is the full breadth of NVIDIA's healthcare and life sciences platform. We span the entire spectrum from robotics in healthcare to medical imaging processing and infusing AI in that, as well as providing software packages for biomolecular science and research. Our approach is to accelerate the entire stack from the bottom up. It starts with our fundamental CUDA-X libraries. For example, cuDF, which is a Pandas equivalent of GPU-accelerated data frame manipulation framework. And this provides raw performance at the lowest level in acceleration. We then wrap these capabilities in high-level, easy-to-use frameworks. This allows you to go from accelerating your initial data libraries to scaling massive foundation models or even data processing, and finally, to optimize at-scale deployment. So with that platform in mind, let's double-click specifically into the biomolecular side of things. So let's start from the data instrumentation side as it leads into the AI training and inferencing. Data instrumentation covers raw data generation on the sequencer. Databricks can speed up whole genomic secondary analysis, for example, by over 135x compared to typical CPU-based workflows. That gives you immediate benefits in secondary analysis. Next is data processing. With rapid single cell, for example, we provide a drop-in replacement for tools that you may already be familiar with, like ScanPy, that delivers massive acceleration over 600 times faster compared to CPU baseline. Next up, for foundation model training, for example, we have BioNeMo recipes and BioNeMo frameworks. In BioNeMo recipes, these are easy, hackable examples that show you how to get started using our libraries like Transformer Engine to speed up training by 4 times on the exact same GPU hardware, for example. And finally, deployment. NVIDIA NIMs allows you to deploy models at production scale instantly. The Boltz 2 NIM, for example, provides an additional 2x speed up over the open source baseline thanks to our own TensorRT optimizations built in. So with that being said, I'm going to pass it over to Srijit to see how some of these foundational components and libraries have been incorporated into Genesis Workbench to translate that value proposition to you, the end user, working on Databricks.
Thanks, Mayank. Let's dive deeper into the architecture of Genesis Workbench. Genesis Workbench is built as a prototype so that you can understand how to build these life sciences applications on Databricks using these open source models, as well as the NVIDIA software stack inside of Databricks workspace. Genesis Workbench is built entirely on Databricks using various platform components like Databricks apps, workflows, MLflow for model registry and model management, model serving for serving the fine-tuned models or the open source model on GPU serving infrastructure, and using Unity Catalog for governance. The NVIDIA BioNeMo stack has been brought into the platform as a Docker container built for Databricks. We use the Databricks Docker container services to host those models on an interactive GPU cluster inside of our workspace. And then you can use this infrastructure to use any of those models, fine-tune using your data, which is in your data plane, and then store those model weights in Unity Catalog, and then serve those fine-tuned models on Databricks GPU model serving. And again, we never stop improving. We knew we had limitations when we started using Docker, so we continued to improve this architecture. Even though it's not available in the application right now, we have proof that this works, and we have now the BioNeMo recipes working well with the Databricks serverless infrastructure. And that will be our version 2 when we release it. And all these are packaged neatly using Databricks asset bundle so that you can take it and install it without any hassle in your environment. Now, Let's take a look at the application sneak peek. So if this is the home page of the application, this is a Streamlit app that's hosted on Databricks apps. Again, this is an open source application and you can always take it, customize it to your needs and tailor it for your workflows. And we will definitely help you achieve what you need to do. But for now, the application is structured based on the field of studies. We have protein studies, we have single cell related functionalities, and we also have functionalities related to NVIDIA software stack. We have NVIDIA BioNeMo as well as NVIDIA Databricks inside the application. If you look at the protein studies, we have hosting some of the foundation models available, open source foundation models that are available today, like RF diffusion, BOLTS, ESM fold, and protein MPNN. We also have AlphaFold. Now, we also show you how to build these workflows where you can use these models to predict the structure of a protein sequence that you have. So here in this example, we are taking the ESM fold, hosting it as an endpoint on Databricks GPU model serving, and then using that endpoint to show the structure of that protein, to get a prediction of the structure of that protein. It's taking some time for the endpoints to warm up, but moving on, we can also look at AlphaFold. So in AlphaFold, it's much more bigger model, and you can see how you take a different approach where we kick off a Databricks workflow that brings up a GPU infrastructure and uses AlphaFold for running predictions of the structure. We could also create workflows for protein design, which creates really new proteins provided a base sequence. When it comes to NVIDIA software stack, look at BioNeMo. We have the ability to now bring in BioNeMo models, fine-tune them, and then fairly easily, like as long as you have your data in a Unity catalog volume, just give the path to that. And then all these parameters, you can set up a regression head or a classification head, provide the advanced parameters that you require, and start a fine-tuning run. That kicks off a run that basically kicks off a Databricks workflow, brings up a GPU infrastructure, loads up the BioNeMo cluster, and then fine-tunes that model and stores the model weights in Unity catalog volume. And now you can use those fine-tuned weights for running your inference, or you can even use those fine-tuned weights to host on a model serving endpoint. Similarly, you can use Databricks. When you install Genesis Workbench, we bring up a cluster that has all the Databricks libraries installed for you. And then you can directly attach a notebook to those Databricks cluster and start working on that straight away. Like you don't have to wait for anything. Once the cluster runs up, the Databricks is already installed for you and set up. Same way for Rapids single cell, we have also integrated for the Rapids single cell stack. We can use that Rapid single cell for single cell analysis. There's an option to use either ScanPy or Rapids for your analysis. So we have been working with several of our life sciences customers to understand their needs and see how they could leverage Genesis Workbench for their day-to-day work. This is one of the quotes that we have got from one of our customers, TetraScience. TetraScience is a company who creates full stack scientific workflows for life science companies. Right. So they have been using Genesis Workbench as a foundation to build their workflows in life sciences. And this is what they told about us. And it's great to hear from customers like TetraScience on how Genesis Workbench is helping them accelerate their work in life sciences. Again, we love to hear what you think. We are open sourcing Genesis Workbench today, and we have a blog that explains how Genesis Workbench works and how it can be installed. Please reach out to your accounts team. If you're using Databricks already, please reach out to your accounts team on how we can help you set up Genesis Workbench in your Databricks workspace. We'd love to hear what you think, how we can help you achieve what you need. Thank you for listening.
Thanks, everyone.